All of your arguments about electrostatics can be resolved by observing the fact that there is no spark between a body and the earth when falling down after being projected upwards. Watch your feet when you jump, therefore it cannot be electricity that causes an object to fall to the ground.
Malcolm, do you agree that objects that hold similar charges don't create static sparks when they touch each other?
Yes.
Fantastic! So long as my charge is not that different from the ground, that should resolve that one.
Kyle, do you agree that a Van de Graaff generator used in classrooms can generate between 50,000 and 100,000 volts?
Yes, Theodore. And do you agree that a Van de Graaff generator can cause things to levitate?
Cause what things to levitate and with what charge? Your question is too vague. Can wind cause a mountain to disappear? These questions are too vague. Get it?
The following clip is from the Plasma Channel, and the guy who runs it is a globe earther.
I'm passionate about physics and energy for a reason, right? Through electrostatics in particular, you can control the world around you. I've demonstrated that with the firebending and with the waterbending. But the implications of this are huge.
Here the guy used his Van de Graaff generator to cause a piece of metal to levitate.
But this isn't about strings or something that you can see. It's about electrostatics.
Theodore, do you agree that this globe earther was able to cause a piece of metal to levitate through the use of his Van de Graaff generator?
Yes.
Kyle, do you agree that this kind of levitation would not work if the foil was replaced with plastic?
Ooh, Twirly Socrates is back from the dead. By all appearances, he has left his days of hypocrisy behind him and changed his mind about whether or not truth can be known with certainty. No, Twirly Socrates, I very much believe that electrostatics is capable of causing plastic to levitate.
Do you agree that the dude says that the effect requires the object to be a conductor?
Let's take a look at that timestamp really quick.
I'm always referring to how positive and negative charges affect one another. It's kind of a common theme / obsession, but levitation of this type relies on just that. When a conductive object is placed between two plates charged to a high voltage, but not in contact, something really interesting happens.
No, he never said that. Though he used a conductor, he never said the word required. Do you agree that plastic can conduct electricity?
No, plastic is an insulator. It's the reason we wrap wires in plastic.
Do you claim this kid's static hair is fake? I think it's interesting how his hair also appears to be levitating.
It's not fake. That's not an example of conduction.
Do you agree that you can get shocked by touching a slide that has been charged?
You can get a static charge by rubbing on the slide, yes. That's not conduction.
If you rub your head on the top of a slide, and a person comes along and touches the slide at the bottom and gets shocked, do you agree that that would be a redistribution of charge?
It is a redistribution of charge between the two people, who are conductors. At no point is charge flowing through the plastic material.
Then how did the person get shocked by touching the slide?
The second person doesn't get shocked by touching the slide. They are shocked when they touch the kid who slid down, or if they touch a surface of the slide that has become highly charged.
Okay, this video acknowledges your claim that plastic is an insulator. However, just because it is an insulator doesn't mean it can't carry or redistribute a charge.
Insulators can have charge. I'm not disputing that. What they can't do is redistribute it, i.e. conduct it.
How are you defining the word redistribute?
In a conductor, any excess charge, electrons are free to move through the material from atom to atom. It causes any excess or deficit of charge to spread out and be diluted throughout the whole object. In contrast, a slide insulator can't do that. If it rubs another object and loses some electrons, then there is a localized patch of charge, and that patch doesn't move.
I don't see how that answers how you are defining the word redistribute.
Redistribute, the dilution process I described.
Do you agree with these definitions of the word distribute?
Sure, disperse is item 2. That's accurate.
How about these definitions of the word disperse?
Sure, to send off in various directions. Conductors spread out the charge within themselves.
Do you agree that this slide dispersed electrons along the surface?
Not in the conductive sense. No, the electrons jumped materials. The slide is not a conductor and the charge doesn't spread out within the plastic itself.
My question didn't claim it went through the slide. My question said, along the surface.
There is no charge moving through the slide. There is no charge moving along the surface of the slide. The electrons are entering the slide from a completely different object.
If that were so, charging one end of the slide should not charge the other.
That's right. Charging one end of the slide does not charge the other end.
Do you agree that if you charge one end of a balloon, the charge will reach the other end of the balloon as well?
No, it is not redistributed. The rubbed portion of the ballon holds an excessive negative charge. It doesn't move.
So if I rub my head with one end of a balloon and try to shock someone with the other end of the balloon, you don't agree that it'll shock them?
The opposite end? Yes, probably no shock.
All right, I've got a balloon. Now I'm just going to charge it up on my head. Can I hear standing up?
Yeah.
I can hear it. Okay. Okay. I'm going to take the opposite end of this balloon. Touch it. No shock. I heard a shock. One more time. Okay. All right. No shock. All right, flip it over. Shock. There's a slight... Okay. You beat me. Good job. Now let's go rewind this and see what dominoes you've knocked over. We first got into this conductive conversation when you told me levitation requires the object to be a conductor.
Do you agree that the dude says that the effect requires the object to be a conductor?
My answer is still no. Do you agree that paper is an insulator?
Yes.
Hello everybody out there in YouTube land. Good time for all here. Zachary Zabala if you prefer. As you can see, whoa, there it went. Oh, it's back. What I have here is just a little piece of paper in between two plates. I have my Van de Graaff generator here with a wire running from the top connected to this bottom plate. I then have the top plate connected down here to the top of the negative discharge ball. So the top plate is negative and the bottom plate is positive. This is opposite to what we see in reality. But as you can see, well, through conduction, for some reason it's getting charged. If I can just keep it going, there you go. When I keep a steady current going to it, it will always stay on the negative, as if the positive is pushing towards the negative evenly in all well, not in all directions, but just from one plate to the other. Now you get near the edges, it's going to go out towards the sides and wrap around towards the top. That's what they call the fringe. It's pretty well understood. Sorry for all the shaking. I'm trying to keep the Van de Graaff. But as you can see, it's just, there you go. It's defying what they call gravity. So there's always a steady current underneath us. There's always a negative field, a charge. and above us is a positive. We're just in this electric field, and we're charged at a certain, we give off a positive charge at a certain rate. All humans do. So we go towards the negative. Things like helium, I believe, are just the ether charged so negatively that they start going towards the positive. And at different charges, it's different levels. So those are your gases. Stuff like that. But that's it. Just wanted to share that with you all. Good times for all here. Signing out. As always, thanks for watching.
You're trying to use electrostatic to prove it is, but where's your independent dependent variable to prove that you change the electrostatic to produce a direct change in the gravitational force that you're measuring, the velocity, the speed of things following?
Let me answer this. Okay. So I use a Van de Graaff generator, which has a little belt on it. It creates friction and creates electrostatic charge, and it makes objects float. It'll change their weight, make them go up, and change how fast they go down. Independent variable electrostatics, dependent variable objects going up or down. I manipulated it, showed the cause and effect. Now you do the same thing for gravity. Go.
I understand the test you're doing. You're creating an electric field underneath the device, which causes it to hover underneath the device. Is
Wrong.
that correct?
You don't even know
How
how
are
it
you doing it
works.
then?
It flips the polarity of the pill based on the two Gaussian surfaces. The field's polarity flips, and then electrostatic transference and induction to the object makes it goes up relative to the polarity of the field.
What? Any object?
Any object. I've done iron filings, hair, styrofoam, rubber, all kinds of like insulators.
Everything that's
wood,
insulators.
anything.
So things. Lead?
Well, in order for lead, I have to have more than my Van de Graaff, which is only about 250,000 volts. But yeah, you can make anything flow with enough electrostatics.